A function is shown. F of x equals x cubed minus 9x over x plus c minus 7. For what value c makes f of x have an infinite discontinuity? All right, so this is talking about discontinuities. Remember, there's three types. We have infinite, we also could have jump, or removable. So those are the three types. Visually speaking, what we've learned is that if you're talking about an infinite discontinuity, the graph will break and go to infinity at a point. So for example, like this graph here would be an infinite discontinuity. A discontinuity is a break in the pieces, and so these would have arrows going on forever in these directions. And you would notice there's a break right here. This break is infinite because at the break, the graph is traveling to infinity. Now, it wouldn't have to look like this. So you could have one piece going up, the other piece going down. But either way, that's an infinite discontinuity. That's what we're looking for. Let me write that over here. This is infinite. So if you wanted to play around your graph and look for it, you need a value like that. Now, as it concerns jump, what a jump would look like is the piece would come out and it would have a stopping point here somewhere, and then it would pick back up and continue on. So it would be something like that. That would be what jump would look like. And the pieces would just kind of jump like that from one place to another. And removable on a graph, you will not see it, but it would just be a little open circle. So like this here, there would have an open circle somewhere. Choose this, you get a little bitty hole here, and you would have a little circle. Now, in the calculator, you won't see that circle, but you could go to Control T and it would say undefined, but yet the picture would look together. So that's how the three pictures, that's the three types of discontinuity. Now let's talk about our problem. The algebra here, what we'd be looking at is I want to know for something to be removable, you have to be able to remove it from the equation. So I'm going to start there, even though it doesn't say removable, though it says infinite. I'm going to start by that. And I noticed in the numerator, I could factor this here. And so if I factor out an x out of the numerator, so I'm doing GCF here, a greatest common factor, I'm left with x squared minus 9 all over x plus c. And then I had the minus 7 on the side. Now, if I continue on, this top part, the numerator still could be factored further. That right there is a perfect square. So since it's a, well, actually we call it a difference of squares, you could factor it as a difference of squares, which is kind of like the square root technique. And it would give us f of x equals, I still have that x out in front, but then these factors, if you just think x method, what are factors of negative 9 that add it to 0? It's 3 and negative 3. So difference of squares just means these both terms are squares. There's a difference. It means a subtraction. You just kind of like take the square root of each. So it'd be x minus 3, and then you have x plus 3 as your other. So now that's my numerator. Now in the denominator, I still haven't changed it. I have x plus c. Now on your answer choices, you'll see some options. If c was a 0, that would go away, and let me just try it this way. If c equaled 0, we could eliminate these two like that, and so we'd have removable at that spot. Okay, you'd have removable discontinuity. I'll just do dot, 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 because I'm going to run out of space. Okay, let's try this again, though. What if, we'll do, or what about if it equaled, if c was negative 3? If c was negative 3, again, this would become negative 3, and guess what we could do? Those could cancel out there. So it cannot equal negative 3 either, or else we'd have removable. And what about if if c equaled positive 3? If c was positive 3, again, we have this, and those would cancel out. So all three of those would be removable discontinuities. So those are answer choices that you have. What makes something infinite? And I forgot over here, this should have a minus 7 on the outside, which really doesn't have anything to do with a discontinuity. That's just a vertical shift down 7 units. C needs to be any other value other than that to be infinite. Now, in your answer choice, I also provided the answer choice 9. So I'll just write here, if C equals, if C does not equal 0, negative 3, or 3, then you would have infinite. Now, in their case, in this problem's case, you would have 9 as your answer choice. Okay, so here the answer should be 9, just because the other answer choice, that really it's infinite if it's anything else, just to be clear on that. It's infinite if it's anything other than 0, -3, or 3. It's infinite. But for this particular problem, we would say the answer is 9 because that was what the other multiple choice option was. So 9 would be your correct answer here.